Good afternoon, and welcome. Whether you like it or not, you are part of this larger BPJ group now. I'm not sure whether it's your first, your second, or your third choice in terms of where you landed, but I hope it's an amazing year for you. There are a couple of these compulsory information sessions that we're going to put together. And compulsory meaning we've put a lot of effort in putting infrastructure in place to set you up for success. And it's necessary that you actually use it. It's compulsory that you actually use it. Because we've changed our workflow to make use of this infrastructure. And this afternoon session we're going to start, and we're specifically going to talk about the repository. So about all of you by now should have received an email that actually said some weird server sent you an email called GitLab and you have to create a password for yourself. If you haven't received such an email, speak to your supervisor or check your junk folder, your spam folder. All right. But I want to start with not directly jump into the repository. Maybe just some myths that we need to debunk as we start this BPJ year. Who of you are really excited about BPJ in terms of your final year project eventually? Right? Only about half. Who of you are really glad where you landed in terms of a supervisor? Who of you are really unhappy about your supervisor? Anybody here? I have to just debunk a couple of myths, and I did some of it via email, but I think some is worth kind of just general discussion. We actually don't have an internal competition in the department to see who gets what students. And frankly, we don't really care that much. It happens to be true, yes, that out of the 9 final year project prizes that were awarded last year at the final year projects evening, 7 out of the 9 came out of our group. But I don't think it necessarily says much about us. We're not going to make your final year project for you. We're going to give inputs into your project. You are the ones that are going to make your project work or not work. Some of you are going to fail miserably. If you do, fail forward, learn from it, and move on. So please, I mean, we don't, even within our kind of group, if you want to call it that. By the way, this optimization group thing is a informal kind of jointly co-evolutionary thing that just grew over time, where we call ourselves the optimization group. It's nothing official. It's just to say, the guys that like to work with numbers in the department typically. So it's not some special group, and you are by association included in that group anyway. It's just an easy way for us to not have to say this person and his students or her students and that person and his and her students. So we refer to it as the optimization group. Right. Please stop me at any point if there's something general about BPJ that you just want to ask, or specifically when we move into the repository. All right. Especially amongst ourselves, myself, Dr. Willemse, Wilna Bean, and Nadia, we don't compete with one another in terms of who students do the best. We actually really don't care that much. We're going to provide all of you with as much input as what we think you can absorb, and a little bit more. And if you make it work, great. And if you fold, oops, we'll cut back a little bit back. Well, yeah. But remember, this is a learning experience. BPJ is not some bar that is set, and we're going to watch and see whether you get over the bar or not. It really is a learning experience. So there should be a lot in your final year project that you don't know. There's still a lot for you to learn. You probably have way more to learn during this final year project than what you have to offer, even though you think you're What's die kat se snorbaarde in English? You're the cat's whiskers. Bee's knees. All right. You've got a lot to learn, and it's fine. At the outset, and you can stop me if I've already mentioned this in that first BPJ session that we actually had. If I do repeat stuff, just bear with me. I think it's important enough to then actually repeat. Your final year project is about 3 sciences. The majority of you are concerned with the science of content. There are new algorithms, there are new software, there are new analyses, there are new things that you have to master, right? And that is great. But that is only one portion. Initially, that will probably be the one that you focus on most, right? And it's fine, but please acknowledge that's not the only. It's but one of 3 sciences that you need to focus on. And I use the phrase science loosely because this is a university, right? This is not a practical college. There's science behind what we're actually teaching. The second one is the science about method. The way in which you're going to approach this final year project, from the start all the way to the day that you actually submit and do your oral presentation. There's an entire methodology behind it that we will provide you inputs with, or inputs about. But it's a science. You can read up on it. You should learn about it throughout the entire year. And it will be new things. And part of what we're going to discuss this afternoon in terms of the repository is about the science of method and why it's actually important. And then the third thing that you really hate us for in the end is the science of packaging. Because trust me, we're going to rip your documents apart. Your diagrams, how you put data into tables, how you write, the flow of your argument. There's science behind it. And you need to study the science of how to write properly as well. It's not just, oops, some have got it and some don't. It's a science and you can study it and you need to study it. And you need to balance the amount of effort that you actually put into these 3. I don't care how fancy an algorithm you write, whether the algorithm is well enough to be defended at master's or PhD level. If you can't package it properly, I won't appreciate it because I can't understand it, right? And you'll likely fail. That's how bad it is. Because at some point, your reader will look at this and say, I've got no idea, just put it over there, right? So please balance the amount of effort that you actually put into the science of content, the science of method, and the science of packaging. Right. Comments, questions so far? Burning questions about BPJ at the start? None? Happy? All right. So there's this thing called the repository. Who of you can associate with this in terms of group work where you email a document back and forth amongst one another? You said, all right, please put on track changes, and you email it, and then somebody screws it up and they make changes, but they don't put on track changes, and now nobody knows who changed what in the document. That ever happened to you? Right? Some say yes, some say no. Good. Have you ever ended up with 3 versions on your, either in email or on your hard drive, with different version names of a file, and you say, all right, this is version 2, this is version 2, I made some changes, underscore, and I fixed some typos, .dox, and then there's a version 2.1, and you think, but what's the difference between all of them? Right. So what we talk about in terms of a repository is version control. And that is part of the science of method. Your methodology to work with documents, to work with data, to work with your algorithms and with the code that you're going to develop. It's about working with that in such a way that is repeatable, and reproducible. And the difference between those 2 are, if you yourself do the same piece of work over again, will you get to exactly the same conclusions? Right, so if you go through the entire process again, will you get exactly the same results and the same conclusions? Or if you take your work and your description of your work and you give it to somebody else, will they get to exactly the same conclusions as what you did on exactly the same data? So it's, again, part of the science of method. And for that, we use a container. We call ours GitLab. It is a specific flavor of something that is called Git. You're familiar with Dropbox, right? You can share things, people can put stuff on there, you can take it off. If you delete something, there's a point-and-click way via the web interface that you can actually get stuff back if you actually deleted it. Essentially, GitLab is just a glorified hardcore version of Dropbox, right? Or iCloud or some shared cloud-based server. But what is important to us is the fact that we can control who works on the files. We know who made changes. We know exactly what changes they made. And it's kind of, so especially when you start working and sharing yourself with your supervisor back and forth, that you don't have to email documents, so that you don't have to change file names. There's one file. It's called My Final Year Project Report, and that's what everybody works on. Your supervisor, you work on it, and it changes, it's got a life, and we can track the entire history of it. And that is the purpose of the repository. It's got a couple of other purposes as well, in terms of backup. My motto is, what is not on GitLab in your final year project does not exist. All right, so if it's not on there, don't tell me, oh, I've got the data. It's not there. Your document, whatever is on GitLab is the official latest version. It's not on there, it doesn't exist. Right, we'll talk about what goes onto GitLab and what doesn't. But ultimately, it's this container that is somewhere in the sky, and we will refer to that as the repository. And it's got a kind of a version. So Git is kind of a successor to Subversion, which is a successor to CVS, which are all version management or version control systems. Some of you have heard of GitHub. It's another flavor of Git. We just happen to call ours GitLab, and we've got a local repository that runs on a server. So essentially what this means, there's this project that have been created for you, and it's typically your initials and your surname. That also happens to be your username on this GitLab server. And you have let's call it a web, how we'll make it kind of let's call that the cloud. And you have a view on what is in that container through http ie repo.up.ac.za. Right, that's the URL that was sent to you that actually said, right, you are now a user, you've been given access to this project, and please go and create a password for you. When you log on to that URL, and we'll get to the logon and the fact that you get a security warning and things like that, that is your web view. So you can look at that repository, you can look at the files that are in there, you can access it only via that kind of web view. It's not the ideal way of working with it, but it's one way. Because if you go through that kind of cloud, there are a couple of cool features that comes with GitLab. The fact that we can have an issue, that you can say, all right, I need something done. I need my supervisor to complete and sign a form for me. I upload it. It's in the repository. I create an issue and I say, dear Mr. and Mrs. Supervisor, please sign this document for me. You assign it to that person. I get an email that actually says, hey, there's a task for you to actually go and do. Once I'm done, I can respond to it. I close the issue, done. So we can have a trail and a couple of online tools. We can create milestones. We can have a discussion on a specific topic. Right, so those are tools that are part of GitLab, this web interface that you actually have. GitLab is built underneath on something that is that is called Git, which is actually under the hood. That's what actually makes all of these things work. GitLab is just a flavor. So what are we trying to achieve with this repository? You will create a little local copy for yourself, which is an exact replica of what is on the server itself. This is called the origin, and I'm not going to go into branches and things like that, but this container that is on a server down in a bunker on the university grounds is the repository. But you can create a local copy on your machine. When you create a local copy, that verb is called a clone. And appropriately so, because it is an exact replica of whatever the latest version is. Along with its history, who changed it, what changes were actually made. And then you create a local copy. So that's part of the value. Suddenly there are 2 copies of your final year project. Right? So if your machine crashes, hey, there's another one. If our server crashes, luckily you've got a copy as well. And we can actually recreate everything. So I don't want anybody throughout this year to tell me, my hard drive crashed, I lost my work. Right? Because you should at most lose a day or 2 days worth of work. So you create, first step is you clone a local copy for yourself. And now you make changes. You add a document, and there are some other documents where you actually change and you add some more text on, let's say, your proposal that you're working on. You make changes. This origin doesn't know what you're doing on your local copy. Right? It does. The fact that you've cloned it, you are now doing your magic on your version. So what you then need to do is get that back onto the repository. And you can do this in a couple of different steps, and we'll go into the more detailed steps just now because I'm not going to cover every bit of the repository. I think we've created enough reading material for you. But you do your changes, and ultimately you push your changes back to the GitLab repository, and that new document is in there along with all of the new changes. On my side, what I can do is I also create, oops, no, definitely not. I also create a little local copy for me, and I do exactly the same thing. You work on something in your document, you realize, oops, I've got a problem. I don't know how to do this, or I want to get feedback on my proposal, for example. You push it to the repository, and what I do is I do the opposite, which is a pull. I did an initial clone. Let's stick to the original. I first do a clone, and once you push stuff back, I can actually do a pull. And suddenly I have a copy of all of your changes locally on my machine as well. Third copy of your document, of your entire BPJ project. Right, so if any one of these crashes, we can still recover your entire final year project. Right, we said this is about the science of method. Good practice in terms of repeatability is if you your computer crashes, we can still repeat everything that you've already done because it exists. You don't have to go and start from scratch all over again. It actually exists elsewhere. And then this becomes a back and forth pushing and pulling of stuff. And this container, the repository, is the central hub through which all of this document movement actually works. Right, it gets a little bit more intricate as we actually go deeper. But at the heart of it, that is it. So I'm going to show you a couple of examples in terms of why this is useful, why we actually feel that this is necessary to actually do. Can I ask that you just jump on your chair and switch the data projector on for us, please? Right, is there anything here that is not that clear, that you don't understand? Any questions that you have so far? Happy? Fine. Right, so there's a repository, which is your project. Initially, you need to do a clone. Once you did your magic, you push the stuff back to the repository, and anybody else that then clones it, clones the original plus all of your changes. And they get the copy of exactly whatever the latest one is. If I can make changes, I make the changes, I push back, and you can do a pull on your side. We don't have to email documents to one another. Why that is actually very useful is each one of these pulls and pushes are what we call incremental, which means it's a very efficient way. Instead of emailing an entire document, we only pull and push those bits that have actually changed. So if it's a 10 megabyte document, and there's only one line that actually changed, it's only that incremental change that is actually being sent. Everything else stays exactly the same. And that is what Git is a fairly intricate system of dealing with those incremental changes. And you can at any point go back to some point in history. All right. There was a question.
So if you're dealing with very sensitive data and it's lying on 3 possible locations, how do we have surety that it's safe in all 3 possible locations?
Number one, because, sorry, that is actually not HTTP, that is HTTPS. And secondly, so that is a secure server, meaning you can't get access to that project unless you are a user on the server, and secondly, you are given privileges to actually access that project.
I'm saying when it's locally on either your computer or your supervisor's computer.
Exactly the same. I mean, if you want to, you can encrypt the data, but that is encryption at a completely different level. If you don't want to have it in too many places, I'm not quite sure where are you heading with this. What is your concern?
That the data could be taken up by some other third party other than this particular setup.
If you email it to me, it's as risky or not more, because then they can hack into Google as well. And that's probably not all that secure. Yes?
I think related to that, the question is also what data goes on GitLab?
We'll get into the little bit more kind of technical bits, I think, a bit later. Let me just show what we're talking about. So a fourth copy of this is actually on a second server, because this repository of ours is backed up on a daily basis. So whoever clones your repository have got a copy. It's on the repository itself, and then the repository is backed up. So there's more than adequate backups. That does not mean you should not have your own protocol in terms of keeping backups of your data. Right, so please do that. We take that very, very seriously. There are a couple of final year projects that are not accessible on GitLab, that are on private repositories specifically for that reason in terms of very sensitive data. In 95% of the cases, I think the data that you're working with is really not all that sensitive. And whatever you publish in your final year project document is anonymized and aggregated to the point where the PDF is really not sensitive at all. So the data itself, sorry, let me rephrase. The data itself may be sensitive in terms of sales data or stuff like that, or actual movements of people or traces that you have in terms of vehicles moving around. But as soon as you start analyzing the data, you aggregate it to the point where it's not that sensitive. All right. Does that answer your question to some extent? I mean, in terms of data sensitivity, I've already, I think, signed 2 non-disclosure agreements for final year project students to not, or to at least acknowledge this is sensitive data, we actually need to deal with this in a secure manner. And that's perfectly fine. I mean, I don't mind that at all. All right, so when you go onto this repository, this is the web interface. You can access this from anywhere where you have a browser. You can probably access it via your phone as well. I think actually there is a GitLab app that you can download and actually use if you want to keep track of who's commented on issues. So that is actually available as well. Very many of you never got to this page in the first place. Either Chrome or Safari or Explorer said, oops, there's a security exception. And the reason for that is that when you go onto ie-repo.up.ac.za, there's some transaction that happens that says, are you really the repository that you say you are? And for that, they work with certificates. Okay, I'll give you my certificate. It's the same as having your ID card when somebody said, well, you tell me you are Joe, but I'm not quite sure that you are Joe, so show me some ID. And in our case, we decided we're not going to pay $10,000 for a security certificate. We sign it ourselves. So you can pretty much trust that if you go to ie-repo.up.ac.za, the repo is our repo. All right, so what you need to do is, I think there's a screen that you can add an exception to actually say, all right, I will accept this this URL on face value. Right, so it's not an error. It is just dealing with the certificates that you need to kind of bypass and accept a self-signed certificate. All right. That then brings you to this GitLab page. Git was initially for programming code, to collaborate in teams. But we use it for a variety of other kind of flat files and data and documents as well. All right, login. Initially, it will just ask you to create a password for yourself, and I think a number of you already have finished that step. So you create your, you can either use your username or you can use your email. You create your password, and then you sign in.